Good evening, everyone. This is topic moles and acid from IAL Chemistry Unit 1. In this session, I'll discuss question from this assignment. So, starting with the first question. In the first question, how many protons, neutrons, and electrons are there in a chloride ion with a mass number of 37? When we check the periodic table, we'll find that chlorine atomic number is 17, but this is a chloride ion. So it is 17 and 37 with a charge of -1. Here A is 37, the nucleon number, and Z is equals to the proton number, which is 17. To find the number of the proton, that is equals to Z, so it is 17. To find the neutron number, that is A minus Z, which is 37 minus 17 equals to 20. And to find the electron number, that is Z minus the charge. So Z is equals to 17 minus, and the charge is -1, so it will be 17 minus minus plus 1, which is equals to 18. So it is having 17 protons, 20 neutrons, and 18 electrons. That's why it matches with option C. In the second question, what is the relative formula mass of hydrated barium hydroxide? So when we work out the mass of hydrated barium hydroxide, so it contains one barium. The hydroxide OH group, it means 2 oxygen here and 8 oxygen. So total it will be 10 oxygen. The number of the hydrogen, 8 multiplied by 2, that's 16, plus 2 is equals to 18. So there are 18 hydrogen. So mass of the barium, that is 137.3, plus 10 times the mass of oxygen, which is 16, plus 18 times the mass of hydrogen, which is 1. So when we multiply and take the sum, it will come out as 315. So D is the right answer. In question 3, an 11 grams of sample of anhydrous sodium sulfate is dissolved in deionized water to form 70 cm cube solution. What is the concentration in mole per dm cube for sodium sulfate in aqueous solution which is formed? So we have 11 grams of anhydrous sodium sulfate. The molar mass or relative molecular mass of sodium sulfate is given 142.1. So first we'll find the moles. So moles equal mass in gram divided by relative molecular mass. The mass in gram is given in the question, that is 11, and relative molar mass, which is given 142.1. So 11 divided by 142.1 equals to 0.077 moles. The volume, because the final answer we need a concentration in mole per dm cube, so volume should be in dm cube. So that is 70 cm cube. So the volume here it is given 70 cm cube. We have to convert into decimeter cube. So to convert cm cube to dm cube, we have to divide by 1000. So 70 divided by 1000, that's equal to 0.07. So moles, to get the concentration, we have moles and volume. Moles divided by volume will get the concentration. Moles are 0.077 and the concentration is equals to 0.07. So 0.077 divided by 0.07, that's equal to 1.1 mole per dm cube. It matches with option C. Moving on to question 4. Barium chloride react with sodium sulfate. The equation is given for this reaction when BaCl2 reacted with Na2SO4 gives BaSO4 and 2 NaCl. So this result in a formation of white precipitate. When we mix two solutions and a solid is formed, so we call this reaction as precipitation. The question is, what would you see when this reaction is carried out? A blue solution form. Blue solution does not form because there is no transition element. Effervescence, not no effervescence because there is no gas given off. No visible change. There is a visible change. Why? Because when we mix two solutions, a solid is formed, and that is white PPT. That's why D is the right answer. What is the ionic equation for this reaction? So how we can write the ionic equation or work out the ionic equation? So we cancel out the common ion in aqueous. So here we have chloride ion common. We cancel out. We have sodium ion common. We cancel out. So we are left with barium ion and sulfate ion, which result in a formation of barium sulfate. So barium ion react with sulfate ion, give barium sulfate. So C is the right answer. In part C, what is the maximum mass of barium sulfate that could be produced from 0.05 gram of barium chloride in this reaction? So if mass is given, we can take the ratio of the mass. We want the mass of barium sulfate and we have the mass of barium chloride. So barium chloride mass is given and we need barium sulfate. So we'll take a ratio of their masses for barium chloride to barium sulfate. So when you check the ratio of the mass, because barium chloride relative molecular mass is 208, so it will be 208.3, and barium sulfate it will be 233.4. So ratio is 208.3 to 233.4, but we have barium chloride in the question. We have only 0.5 grams of barium chloride, so this will be x cross multiply. So when we solve, it will come out as 0.560 grams of barium sulfate. The next part, what is atom economy by mass formation of a barium sulfate? So the atom economy, that is mass of the desired product divided by total mass of reactant or product into 100. So we want to work out the atom economy, the percentage atom economy, that is equals to mass of desired product divided by total mass of the reactant or product into 100. So mass of our desired product, because we are finding the atom economy here for barium sulfate, so that is our desired product. So the total mass of barium sulfate, that is 233.4, divided by total mass of reactant barium chloride plus sodium sulfate. So barium chloride is 208.3 plus sodium sulfate is 142.1, and that is multiplied by 100. So 233.4 divided by 208.3 plus 142.1 into 100. This will give us the percentage atom economy. That will come out as 66.6%. So C is the right answer for part D. Now in question 5, this question is about ethene C2H4. The global production of ethene is about 150 million tons per year. Calculate the number of molecules in 150 million tons. So first we have to get the moles, and from moles we'll find the number of the particles. So the formula: moles equal mass in gram divided by molar mass. So the mass in grams, it's 150 million. As I mentioned here in the question, it is 150 million tons. So 150 million, first we have to convert this 150 million into kilogram and then into, so it is 150 into 10 to the power 6 tons. Then we have to convert into kilogram. So if you want to convert into kilogram, as we know, 1 ton is equals to 1000 kilogram. So we'll multiply by 1000, convert into kg. So it will be 150 into 10 to the power 9. And then this is in kilogram, but we have to convert into gram. So to convert kilogram into gram, we'll again multiply by 1000. So it will come out as 150 into 10 to the power 12. So this is 150 into 10 to the power 12 grams divided by molar mass of ethene. So carbon is 12 multiplied by 2, so which make 24, plus hydrogen is 1 multiplied by 4, so the total will be 28. So this will be divided by 28 to get the moles. So the moles will be 5.35 into 10 to the power 12. We know the formula which relate the moles and the number of the particles. So moles equal number of particles. It can be atom, molecule or ion divided by Avogadro's number, which is 6 into 10 to the power 23. So we have the moles. We need the number of the particles. The number of particle will be moles multiplied by Avogadro's number. The number of the particle here, uh, to work out, so first the moles 5.35 into 10 to the power 12. Number of particles is unknown, and Avogadro's number 6 exponent 23. So this will be multiplied there. We get the number of the particle as 3.22 into 10 to the power 36 particles will be there for ethene. In the next part, ethene is used commercially to speed up the ripening of bananas. Ethene level of 100 parts per million is used in ripening room. Calculate the amount of in moles for ethene in a ripening room with the volume is there 220 meter cube. The temperature is there 21 degrees centigrade and the pressure is there 1.01 into 10 to the power 5. So we have the formula. They give you the hint that PV is equals to nRT, the general gas equation. The value of R is given, but all should be in the standard values. The SI unit should be there because the temperature is given in degree centigrade, so we have to convert into Kelvin. So as I mentioned here about the temperature, we'll add 273 to convert this temperature into Kelvin. So it is 21 plus 273, which is equals to 294 Kelvin. And we have the formula PV is equals to nRT, so N is equals to PV over RT. These are the topic wise questions related to moles and acid I'm solving. So P is the pressure, which is 1 into 10 to the power 5 Pascal or 1.01 into 10 to the power 5 Pascal. multiplied by V is the volume, which is already in meter cube, 220. The general gas constant is 8.31 into the temperature in Kelvin, which is 294. So when we solve this, we'll get the number of the moles. That will come out as 0.91 moles. The value of the N is representing the number of moles. This 0.91, because we need the moles of ethene here, as you can see, this part, they mentioned that ethene is used commercially to speed up the ripening, and calculate ethene level is 100 parts per million in the ripening group. So these are the number of the particles, but ethene will be 100 parts per million. That's a concentration of ethene is given. So this answer here, that will be 9994.9. That is the value of N, the total number of the particles. But to get the number of the particles of ethene, the concentration in ppm is equals to moles of ethene divided by moles of ethene, which is C2H4, divided by moles of the gas, which is used, into 1 million. So we need the moles of ethene. Concentration is given for ethene, which is 100. Moles of a gas we've already worked out, that is 9094.9. So we have this value, concentration is there, and we can find the moles for ethene. Is it clear? In the next question, question 6, which is multiple choice question, how many molecules are there in 44 grams of carbon monoxide? So how we can find the number of the molecules? The formula for first for moles equal mass in gram divided by molar mass. The mass in gram, that is 44, divided by molar mass of carbon monoxide. So carbon is 12 plus oxygen is 16. That will make 28. So 44 divided by 28, we'll get the moles, which is 1.57. So 1.57 are the moles for carbon monoxide. But we need the number of the particles. The formula which relate the moles with number of the particles, moles equal number of the particles divided by Avogadro's number, which is 6 into 10 to the power 23. So 1.57, number of the particles unknown, and we have Avogadro's constant, which is 6 into 10 to the power 23. This will be multiplied there. So 1.57 into 6 into 10 to the power 23. This will be 9.46 into 10 to the power 23. So C will be the right answer. A compound has a relative molecular mass of 84 and its composition 71.4% carbon, 9.6% hydrogen, and 19% oxygen. What is the molecular formula? So before finding the molecular formula, we should know the empirical formula, because molecular formula is empirical formula times N. And what is N here? N is the molecular mass divided by empirical mass. So first we will find the empirical formula from the percentages. The carbon, that is 71.4%, hydrogen 9.6%, and oxygen is there, which is 19%. The first step, we'll divide by atomic mass. So this carbon atomic mass is 12, hydrogen is 1, and oxygen is 16. So 71.4 divided by 12, that is equals to 5.95. This will be 9.6, and this will be 19 divided by 16, that's equal to 1.187. Then divide by the smallest value. So we'll divide by 1.187. So 5.95 divided by 1.187, that's equal to 5. Hydrogen 9.6 divided by 1.187, that's equal to 8, and oxygen is 1. So empirical formula is C5, H8, and O. Then to get the empirical mass, the molecule empirical mass, this is empirical formula. So from empirical formula we'll find empirical mass. So carbon is 12 multiplied by 5, plus hydrogen is 1 multiplied by 8, plus oxygen is 16. So that will be 60 plus 8, 68, and plus 16, that's equal to 84. So we have the same molecular mass, and empirical masses are same. So value of N will be 1, because N is molecular mass divided by empirical mass. So 84 divided by 84, that's equal to 1. So molecular formula is equals to empirical formula times N, and empirical formula is C5H8O, and that times 1. So we'll get the same as molecular empirical formula, and molecular formula will be same. So it will be C5H8 and O. So it matches with option C. So C is the right answer for question 7. In question 8, the formula for barium chloride, which is the correct statement about the barium chloride? Barium chloride exists as a molecule. It's an ionic compound. Ionic compound does not exist as a molecule, so that's wrong. Barium chloride is a compound, that's true. So B is the right answer. What about other options? The empirical formula of barium chloride is BaCl. That's wrong. Actually, this BaCl2 is the simplest ratio of the ions present in the structure. So the empirical formula should be BaCl2. The relative molecular mass of barium chloride is 172.8. So when we work out, barium is 137.3 plus chlorine is 35.5 multiplied by 2. So 137, this will be 71, 35.5 multiplied by 2, that's 71, and 137. So 137.3 plus 71, that will be equal to 208.3, but it is written 172.8, so that is also wrong. So correct option is B. In question 9, What is the percentage atom economy by mass for the production of hydrogen in the reaction shown? The relative atomic masses are given. For production of hydrogen, the formula for percentage atom economy is the mass of desired product divided by total mass of reactant or product into 100. That is for percentage atom economy. So mass of desired product, hydrogen is a desired product here. So total mass 3 multiplied by 2, that's equal to 6. Divided by total mass of the reactant. So carbon is 12 plus hydrogen 1 into 4, so that is 16, plus water mass is 18, so 18 plus 16, that's equal to 34 into 100. So 6 divided by 34 into 100. So 6 divided by 34 multiplied by 100, that's equal to 17.6% atom economy of hydrogen by mass. So the correct answer for this question is B. Is it clear? Any doubt till now? If you have any doubt or you want me to repeat any question, you can use the chat or you can use your mic. In question 10, this question is about the compound ammonium dichromate. Ammonium dichromate break down at around 180 degrees centigrade, producing an oxide of chromium, nitrogen and water as only products. Write an equation for this reaction, and state symbols are not required. So you don't have to mention the states of the product, but you should write a balance equation. So this is a thermal decomposition. As I mentioned, it decomposed to give oxide of chromium, nitrogen and water. So we have ammonium chromate, so it gives nitrogen, it gives oxide of chromium. And what is the oxidation number of the chromium here in this compound? As I mentioned, it is chromium 6. So if oxide of chromium is there, chromium is plus 6 and oxygen is minus 2. So when we simplify this, it will be Cr. This will be 3 and 1, so it will be CrO3. As a normal chromium 6 oxide. But if the oxidation number changes, then the formula will also change for this chromium oxide. So we will have to write the balance equation for this. And in the question, producing oxide of a chromium, so they did not specify, because the possibilities are there. It might produce a chromium 6 oxide or it might produce chromium 3 oxide. In dichromate, it is oxidation number, but normally when a chromium oxide is formed, chromium is plus 3 and oxygen is minus 2. So it will form Cr2O3. These are the common oxides of chromium. So it produces a chromium oxide, that's why we are taking Cr2O3 plus nitrogen N2, and water is the only products, H2O. Then we have to balance. Whenever we try to balance, we start with oxygen followed by hydrogen and then other elements. So we have 7 oxygen, 3 are already there. So we have to just balance the oxygen number. So we put 4, so oxygen will be balanced. What about hydrogen? 4 multiplied by 2, 8. So hydrogen is already balanced. and chromium is also balanced. So this is the balance equation for thermal decomposition of ammonium dichromate. Give the name of this type of reaction. So what we call this type of reaction, when one reactant give more product, we call that as thermal decomposition. In part B, when 0.001 moles of ammonium dichromate was heated, 25.2 cm cube of nitrogen gas is measured at lab was formed. Calculate the temperature in the lab in degrees Celsius using the ideal gas equation. Use atmospheric pressure as 101 kilopascal or 101 into 10 power 3 Pascal. PV is equals to nRT. So using PV is equals to nRT, first we'll get the moles of nitrogen, and from moles of the nitrogen we can work out the temperature of the gas, and the temperature of the gas will be same as the temperature of the surrounding. Where P is the pressure, V is the volume, N are the number of moles, R is the general gas constant, and T is the temperature, which we are finding. So pressure should be in all should be in SI units. So pressure is 101 kilopascal. So it should be 101 into 10 power 3 Pascal. V is the volume, and in the question they give this volume in cm cube, but we have to convert the cm cube into meter cube, centimeter cube into meter cube, because the SI unit of volume is meter cube. So to convert centimeter cube into meter cube, what we'll do, because to convert centimeter into meter we divide by 100, but it is centimeter cube into meter cube, so we will divide by 100 cube. So 25.2 divided by 100 cube, this will come out as 2.52 into 10 power minus 5 meter cube. Then the number of the moles they already mentioned in the question. That is 0.001, the value of the N. So we substitute, and the value of general gas constant, it is 8.31. So we have the formula PV is equals to nRT, where P is the pressure, that's equal to 101 into 10 power 3. V is the volume, which is 2.52 into 10 power minus 5. N are the number of the moles of the gas, nitrogen 0.001. R is the general gas constant 8.31, and T is the temperature. When we solve this, we'll get the answer in SI unit. SI unit of temperature is Kelvin. So this answer will be in Kelvin. So when we solve, this will come out as 306.28 Kelvin. But they are asking in degrees centigrade, so we know temperature in Kelvin is equals to temperature in degrees centigrade plus 273. So temperature in Kelvin is there, which is 306.28, equal temperature in degrees centigrade. We want to find, that's unknown, and plus 273. So 273 will move to other side. That will be minus 273. So we'll get the temperature in degree centigrade, which is 33.3 degree centigrade. Then draw a dot and cross diagram of ammonium ion. Use dot and cross for nitrogen. Use dot for nitrogen and cross for hydrogen. So in ammonium ion, there is a dative bond. So we have nitrogen, which belongs to group 5. So nitrogen is having 5 electrons in the outermost shell. These are the electrons of nitrogen. Then it's shared from 3 covalent bond, first with hydrogen, and then there is one of the bond is a dative bond, so that the charge on this ion will be positive. When both electrons are shared from one of the atom, we call that as a dative covalent bond or coordinate covalent bond. Explain the shape of ammonium ion using the electron pair repulsion theory. So what will be the shape of electron pair according to electron pair repulsion theory? When we predict the shape, we check the number of the bond pair and number of lone pairs. So you can the dative bond also considered as one. So this is one electron bond pair, second bond pair, third bond pair, and four bond pair. So there are four bond pair and there is no lone pair. So when we have four bond pairs and there is no lone pair, so it will have a tetrahedral geometry with a bond angle of 104, 109.5, not 104, it's 109.5 degree. So it will have a tetrahedral geometry because there are four bond pairs and electrons are arranged in a position of minimum repulsion. So this supports a tetrahedral geometry. In next part, ammonium dichromate comes from several warning on packaging. They mention that this compound is toxic when inhaled and by passing through the skin. Handle with extreme caution, and contact can irritate and can burn the skin or the eye with a possible eye damage. Inhaling can irritate nose and throat, and ammonium dichromate is a strong oxidizer that enhances the combustion of other substances. Oxidizing agents enhance the combustion for other substances. So we have to tick the boxes, the relevant boxes according to the warning on the package. So because it is oxidant, so this is symbol for oxidant. This means it's a violent reaction. This means it's a flammable substance, but itself it is not flammable. It is oxidizing, so it can cause fire or combustion of other substances, not flammable. Then they mention contact can irritate or burn the skin or eye, so this should be checked as well. Toxic, a toxic chemical, this is a symbol for the toxic substance. And handle with extreme caution, so we should be caution. So we have to take these parts. This is if it was a violent or explosive reaction, then we'll take this box, and if it is flammable substance, we'll take this one, but we don't have to, because according to the warning on the packaging, we have to mention it is oxidizing, irritant, toxic, and it must be handled with caution. Suggests why ammonium dichromate is not stored in the same cupboard as alkane. So as I already mentioned in the question, that it can cause the combustion of flammable substance, or it is oxidizing. So it is oxidizing agent. It can help or promote burning of alkane. That is why it is not stored in the same cupboard as alkane. So oxidizing agent, and it can cause combustion of alkanes. So these are some questions related to topic moles and acids. Next session I will discuss more questions from this moles and acid.